Oh, there's some homework. There's some homework. But you guys have tomorrow off. Right, Olivia? Right?
No, I don't know.
Oh, you want to be here? So tomorrow, Veterans Day, my 6th period class is going to have to do something fun, you know, because you guys missed class. Because they're doing the same thing as you guys today. Yeah. You guys missed class. Friday, 5-2 notes. And we'll move on.
Yeah, Mr. Westfall.
Yeah. How do you know?
I think it should just be 1 through 5.
How do you know there's a lot of homework? You haven't looked at it yet.
You just said it.
No, not number of problems. What if it said, oh, name this triangle, scalene, isosceles, equilateral? Boom, done. 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 Well, then we better learn it today. Anthony. Oh, that's a typo.
Just take it off there. Take it off.
Yeah, that's a typo. I'll take it off. I'll make it 34 through 37.
Wait, yeah, just 13 hours.
All right, please read through these quickly.
I got it.
All right. You are responsible for classifying triangles by sides and by angle measures. They are two different categories. If I say, name this triangle by its sides, your options are scalene, isosceles, and equilateral. This is kind of weird. I don't know if you've seen it this way before, where isosceles, we might say 2 congruent sides. What does it say? At least 2 congruent sides. So what does that mean? That means an equilateral is also isosceles. Make sense?
But if it's a triangle, it has to have 2.
Triangles have 3 sides. Isosceles are at least 2 congruent sides. Equilateral, all 3 sides have to be congruent. Okay? All 3 sides have to be congruent. Next, so those are your choices. All right? Now, what about angles? Your options for angles, there are 4 options. Are you ready? How cute. Aw. So cute. Right? Obtuse and equiangular. Have you heard that word?
No.
Ooh, that's a new one. That's exciting because we're learning new things. Equiangular. Guess what students confused frequently? Equilateral, equiangular, right? So how do we keep them straight? Well, obviously, equiangular has the word angle in it. Equal angle. Lateral, equilateral. You've heard it before, haven't you? You probably took it for granted. What does lateral mean? We've heard that. Lat, L-A-T. Latitude. Ooh, show me which way do latitude lines go. Wrong. This is longitude. Latitude, side to side. Side to side. All right, moving on. In football, a lateral, you can toss it to the side or behind, right? To the side or behind. Ooh, side, lat. Right? Lat. Ooh, doing lats. Work on some lats today, all right? You're doing this.
Yeah, I know they are.
Aren't they the muscles like on the sides right here? Those are your traps. Lats. Right? Yeah, on the sides. Ooh, latitude. Lats. Side. Equal sides, equal angles. All right? Obviously, equiangular has the word angle in it. Easy to remember. So how many options if I say classify by side length? 3. How about angle measure? 4. I'm guessing some of those homework problems, easy, quick. Name, classify. Moving on. All right, do you see this red triangle up here? It's kind of hard to see. Can you see the tick marks? Tick marks mean congruent. I see 2 congruent sides in this triangle. I see 2 congruent angles in this triangle. Let's read the directions. Classify the triangular shape of the support beams in the photo by its sides and by its angle measures. Well, by side, we would call it Isosceles. I think that's right. I don't know. All right. By angles. This is just a warm up for us. Just a warm up. Aw. So cute. That's a good pickup line, guys. Okay. Hey, if you were a triangle, you'd be a cube.
I would
It doesn't work.
Just ask my wife. Ask her. Ask her.
It
Man,
doesn't work.
20 years ago, it's a great day. So we sealed the deal. Just kidding. All right, that'd be embarrassing. All right, now that we've made fun of me enough, moving on. We have this picture. It is graphed out for us. We're gonna have to dig deep here, friends, and those who aren't friends. All right, classified by its sides. Then determine whether it is a right triangle. Ooh. This is a deep question here. Ooh. By sides. I heard someone whisper it. How do you know?
It looks like it.
That's lazy. Don't be lazy. How are we going to find the side lengths?
Distance formula.
The distance formula. We're going to have to find PO, then OQ, and then PQ, and then compare them. Let's do this. Let's do this. PO. Shh. Hey guys, we have to move quickly through this. Because you know what happens when we don't get through it. You're sitting there, trying your homework. But he never taught us this. You know who you are. You know.
I do that even if you don't.
All right, now here's the thing. I need you guys to listen. These x1, y1s and x2, y2s are going to be changing because we are going to be doing this several times. So just because O is an x2, y2 right now, it could be an x1, y1 in the next one. Do you see what I'm saying?
Yeah.
It doesn't have to be. Does it really matter what you call it? No. Do you know the formula though? Do you remember the distance formula?
Yeah.
Okay. Yeah, we do the difference of the x's in this one. We do the difference of the y's in this one. We're going to do this quickly because we've done it in a chapter. We've done it multiple times this year. We're confident in this process, aren't we? We have 0 minus a -1 in that one. We have a 0 minus a 2 in that one. Let's do PO. PO is the square root of what's 0 minus a -1? It is 1. 1 minus a negative plus 1 squared. 1. Is this thing on? Are we good?
Yes.
1 squared? 1 times 1?
Yeah.
1. -2 squared. 4. 1 plus 4? Square root of 5 is that length. Do you agree? Do you agree? I don't care what it is right now. Anywhere, did it say anywhere in the problem to list the lengths of each side? No. And I know you guys. You don't want to do any more work than you have to. So, I do know that's a little more than 2. I don't care right now. All I care is the next time I get a side length, is it the same as that or is it different? Right? Now, I know what you're going to say. Well, Mr. Westphal, I know obviously that one's longer than that because of the picture. I know too. But sometimes you don't. It's close. All right? So we have to actually find them by their lengths. Here we go. OQ. OQ is our next point. I guess since we called that one x2, y2, let's call this one x1, y1, just so we don't have to erase. So we're going to do a 0 minus a 6 squared plus a 0 minus a 3 squared. Let's cut straight to the final answer. What'd you get? I got the square root of 45. which is between what two whole numbers? We're not typing it in, but what's it between? Between what two whole numbers? Okay, this is something we don't know. That's okay. What's the square root of 36?
6.
What's the square root of 49?
7.
Is it between 6 and 7?
Probably.
Are you? So if this is a unit, look, these little squares are 1 by 1 units. They could be inches, they could be miles, they could be kilometers. I don't know. They're 1 by 1 units. If those are 1 by 1 units, then the length of this segment is between 6 and 7 units long. Do you get that? Okay, awesome. Last one. QP. QP? Well, let's just change this to an x2, y2, make it easy. All right, here we go. So let's do a -1 minus a 6 and a 2 minus a 3. What's -1 minus 6? -7 squared. 49. What's a 2 minus a 3? -1. Squared? 1. Square root of 50. Square root of 50, which is a little bit more than 7. Because square root of 49 was 7. A little more than 7 units. Are any of these three the same? No. So if we're classifying by side length, we would call it scalene. Very good. Scalene. Be very, very careful. I think you could see there's a lot of room for error with signs in this problem. What do I mean by that? Subtracting a negative, adding numbers together, right? There's a lot of room for error. Whenever you square a number, it's going to be what? Positive. So if you have -7 squared, if you're typing it in your calculator, just put a parentheses around that -7. Because it's not -7 squared. It's -7 times -7. It's 49, right? You should know that. Don't just trust your calculator if you accidentally type it in wrong. Last question. Is this a right triangle?
No.
How can you tell? Tyler, what do you think?
Slope.
Slope. Good. What are you looking for?
5/1.
Right, but what kind of relationship are you looking for if there's a right angle?
It's
Do you remember that?
negative.
You remember? Okay, let's go through our train of thought here. If there's going to be a right angle in this picture, two of the segments have to come together at a right angle, which means they are perpendicular. Very good. If two lines are perpendicular, their slopes are opposite reciprocals. Perpendicular lines have opposite reciprocal slopes. Tell you what, you got a graph. Let's just count slope. What's the slope of, and here's how I like to write it. I would highly encourage you to write this the same way. M we use for slope, right? I put a little PQ below it to remind me I'm finding the slope of PQ. Well, from P to Q, I go down 2 and right 1. Down 2, right 1. That's -2. Agree? You don't have to use the formula. We can count on a graph. If we had to use the formula, did I do something wrong? Oh, I said PQ, but I meant PO. Sorry. PO. I saw some weird looks, which can sometimes be your normal faces, but whatever. Just kidding. Oh, ouch. I went from P to O, not P to Q. P to O. Down 2, right 1. How would I find it if I didn't have a graph? I'd have to use the slope formula, which is y2 minus y1 over x2 minus. I don't want to do that right now because I have a graph. I can count. Can you count? I mean, I can count on you. All right. How about O to Q? How about O to Q? What's the slope? Well, we have to go up 1, 2, 3. Slope of OQ is up 3. 1, 2, 3. Run 1, 2, 3, 4, 5, 6. Should I just leave it as 3 over 6? No, reduce. 1 half. Reuse. Recycle. Thank you. Is that Jared? Preston? Would it be earth aware? Are those opposite reciprocals?
Yes.
Yeah,
Yes, they are.
they're opposite.
Because it's 2 over 1.
Is negative 2 over 1 the opposite reciprocal of 1 over 2?
Yes.
Last time I checked. So, these two segments that we just found the slope of are perpendicular, meaning there's a right angle there. Could there be another right angle in this triangle? Why not?
Because it's nice. Because it's scaling. JK.
Tyler, what do you think?
The interior angles of triangle must equal 180. So if 2 90 degrees would just make 2 straight lines.
Yeah, so if there's 3 angles in a triangle, and they add up to 180, what happens if there's 2 90s? Aw, this little guy has 0 degrees left it can have. Can't have a triangle that way. Do you agree?
Yeah.
Can't be 2 right angles in a triangle. Cannot be 2 right angles in a triangle. All right. So, is this a right triangle? Yes. So yes. And I would say our argument is yes. Right triangle. Because PO, the slope of PO, and it's getting glitchy, the slope of OQ, that's an OQ, are opposite, come on, you can do it, reciprocals. It's kind of glitchy. Are opposite reciprocals. It'll probably say either explain or show your work. And so in this scenario, we showed that both slopes are opposite reciprocals.
Are we doing proofs in this?
Yes.
No.
It's okay. It's okay. They're getting better. They're going to get better. I'm going to go out on a limb, and you're not going to believe me right now. And I know you guys hated me. You probably still hate me because of proofs, because you don't like geometry, or maybe you just don't like me. But proofs are going to get better. Proofs are going to get better. Triangle congruence proofs are the easiest proofs we're going to do.
I don't believe. Neither do I.
Emma, I appreciate your honesty. Even if it causes me to go home and cry, I appreciate your honesty. Okay?
That's fair enough.
No, the last
Proofs are like my name.
All right, next. Is this on your paper?
Yeah. No.
I don't think so.
All right. When the sides of a polygon are extended, other angles are formed. And you don't need to write this down. It should be obvious to you. Okay. When you have 3 lines intersect, can you see that what's inside is called the interior angles,
Yeah.
and what's outside are called the exterior angles? Okay. Awesome. Perfect. That's all you need to know. Now, what we need to take from that. Here's what we need to take from that. Tyler brought this up a little bit ago. Do you remember that the sum of the 3 interior angles of a triangle is always 180?
Yeah.
The sum, add them up, of the 3 interior angles of a triangle is always 180. That slide was there twice. All right. How could we prove this? Let's make a line. We're going to run out of time. Oh, we have 4 minutes. I forget if this is on yours or not. Kind of. It's a proof, isn't it? The proof of the triangle sum theorem.
Yeah.
Here's where this comes from. Okay, you're allowed to draw in your own line in a proof. We're not going to do it often, but in this scenario, I'm drawing this line in to be parallel. And did the numbers go 1, 2, and 3 from 4, 2, and 5, aren't they? 4, 2, and 5. And then was it 1 for angle A? And 3 here. Okay. Here's where we're heading for tomorrow. Not tomorrow, Friday. Eyes up here. What can you tell me about angles 4, 2, and 5?
They make a 180.
Thank you. Together they form a line. We're not going to call them a linear pair because pair means 2. But they are a linear trio. Linear trio. I like it. So would you agree 4 plus 2 plus 5 equals 180? Angle 4 plus 2 plus 5. Now, I'm not going to have time to do this, but the proof would look something like this. 4 plus 2 plus 5 equals 180. The linear trio theorem. Okay? Now, since we just made parallel lines, what kind of angles are these if this is a transversal? 3 and 5 are congruent because they are alternate interior. 4 and 1 are congruent because they're alternate interior. Well, if 4 plus 2 plus 5 equals 180 and 4 and 1 are the same, couldn't I put a 1 in for 4? And couldn't I keep 2 the same? And couldn't I put in what could I put in for 5? 3? Ooh. What did I just show? By substitution, I just showed that 1 plus 2 plus 3 equals 180. What are 1, 2, and 3? The interior angles of the triangle. Okay? That's not for you to formalize on a proof because we're running out of time. I wanted to at least show you.
We do have one announcement. Attention middle school dad band members. There is no middle school dad band at the school today. Middle school band members, no middle school dad band.
Hey guys, before you pack up, or else you're going to be doing a lot of extra homework. Maybe not a lot. I'm cutting it down. You want to look at it later? All right, here's what I will say. 1 through 5, 12, 13.
It's all better. Of course, I put things that I'm going to be making.
Yeah, hold off, guys. I'm kind of changing these a bit. All right, there's the assignment if you want to write it down now.
Stack it on to Friday. Are we gonna have any proofs on the homework?
No.
Because I did not know where to write that one.
Yep. No, I told you guys we ran out of time. We'll formalize it on Friday.